Okay, this video is going to demonstrate how you go about writing and balancing an equation correctly. Okay, the first thing that you're going to do here is you got to take each part and translate into its chemical formula. So we've got zinc plus sulfur produces a compound, zinc sulfide. So for elements, it's real simple. You just simply write down their symbol. So the symbol for zinc is Zn, plus sulfur, which is S. Don't forget to include your yields arrow. Now for zinc sulfide, we have to write the binary compound. So we look up on our oxidation number table, we see that zinc is plus 2. Sulfide, the ide ending means sulfur, so that would be negative 2. They add to 0, so we just put the 2 together. So the very first step is always getting the correct symbols written down, whether it be the symbols of the elements or writing out the correct binary compound. Then all we simply have to do is count. We count everything on the reactant side and compare it everything over here on the product side. So I have 1 zinc, that's balanced. 1 sulfur, 1 sulfur, that's balanced. So if they balance automatically when you write it all out, I want you to write the word BAL right over the yields arrow to show me that that's done. Okay, so on number 2, we have potassium chloride plus silver nitrate will produce silver chloride plus potassium nitrate. So I've got compounds everywhere. So first thing I always do is just go look up their oxidation number. Potassium is +1, chloride's -1, silver is +1, nitrate, polyatomic, -1, silver was +1, chloride -1, potassium is +1, and nitrate was -1. So I need to write the correct binary compound. So those two add to 0, so they just go together. So that would be KCl plus silver nitrate, which would be AgNO3, produces silver chloride, which would be AgCl plus potassium nitrate, which would be KNO3. So now that I know that I've written them correctly, I can count. So I have 1 potassium, they're okay. 1 chlorine, 1 chlorine, it's okay. 1 silver, 1 silver, it's okay. Now the nitrate group, I have 1. And over here, I have 1. So they're okay. You could count them individually. You could count 1 nitrogen, 1 nitrogen. But I like to just, since they're polyatomics and they go as a group, I just do them together. So since they're all okay, and I didn't have to change anything, this one is balanced as is. On number 3, we've got calcium, that's +2. Oxide the ide ending means oxygen, so that's -2. Hydrogen, +1. Oxide, -2. Calcium, +2. Hydroxide, that's a polyatomic, and that's -1. So I take each part separately. We've got calcium oxide, they just go together, plus hydrogen oxide, so we know that that's H, the 2 comes down, and then O. It's another name for water, by the way. And then calcium hydroxide, so we've got calcium, we don't need to write the 1, and we have hydroxide with the 2 down here, and since it's polyatomic, I need to put that in parentheses. So once I've written them correctly, I can then count. Now, anytime you have hydrogen, I always count it last, and you'll see why when I start counting. So when I start counting calciums, I have 1 calcium, 1 calcium, it's okay. I have oxygen on the reactant side, I have 1 plus another one is 2. Over here I have 1 times 2 is 2. So hydrogens are okay, or oxygens are okay. Hydrogens, I have 2 here, and I have 1 times 2 is 2. So this one is also balanced as written. On number 4, I have sodium hydroxide plus hydrogen chloride, sodium chloride, and hydrogen oxide. And again, I just go through and I write down the oxidation numbers. I look them up on my list if I have to. After a while, you'll start memorizing these. Okay, so sodium hydroxide, NaOH, these go together, plus hydrogen chloride, HCl, they go together. We'll produce sodium chloride, NaCl, plus hydrogen oxide, which is H2O. You have to do a cross there. Now I'm going to count. When you start to count, you always do hydrogens last. So sodium 1, 1, it's okay. I'm going to go to chlorine 1, 1, it's okay. Oxygen, I have 1 here, 1 here, it's okay. And hydrogen, I got 1 plus 1 more is 2, and I have 2 over here. So this one is also balanced as written. On number 5, I've got magnesium bromide, so magnesium is plus 2, bromine is minus 1. Chlorine is an element, so it has no oxidation number. Magnesium chloride is plus 2. Chlorine in the chloride form is minus 1. And bromine is an element, no oxidation number. Now, one of the things we need to note were chlorine and bromine, they're on the diatomic 7 list. So that's going to come important when you write down their symbols. So since these don't add to 0, I'm going to have to cross. So you got Mg, Br2. Chlorine is diatomic, so it will be Cl2. Produces Mg, Cl2, plus bromine, and if you check your list, bromine is also diatomic. So you have to write it as Br2. So once I've written them correctly, then all I need to do is count. So I have magnesium 1, magnesium 1. Bromine 2, 2. Chlorine 2, 2. So this one, as written, is balanced. And the key would be the diatomics. These guys up here, these two elements, when they're completely by themselves, are diatomic, not when they're part of a compound. Okay, so on number 6, again, I've got sodium chloride, compound, plus hydrogen sulfate, compound, sodium sulfate, another compound, hydrogen chloride. So I go through and I write down my oxidation numbers. I got plus 1, minus 1, plus 1, minus 2, plus 1, minus 2, plus 1, minus 1. I always just do that at the beginning so that I know when I'm writing out my compounds. So for sodium chloride, it'd be NaCl, they just go together, plus hydrogen sulfate would be H2, sulfate is SO4. We'll produce sodium sulfate, which would be Na2SO4, plus hydrogen chloride, HCl. Okay, so now that I've written them right, I can start to look at my balancing. So here I have 1 sodium, but I end with 2. If I end with 2, I've got to begin with 2. So I'm going to need 2, and I'm going to use the coefficient 2. I can't stick a 2 in between anything in a compound. It has to go in front of the first element. So now that means I have 2 chlorines. 2 times 1 is 2, and I only have 1 over here. So I'm going to need 2. So it has to go in front. Sulfate groups, I have 1 SO4, 1 SO4. Hydrogens, I have 2, and I end with 2 now. And that's why I always do hydrogens last, because it will almost always fix itself when you balance other things. So this one I had to use coefficient numbers here to balance out the equation. So what it says is I need twice as much sodium chloride, then I do hydrogen sulfate, and I will make 1 unit of sodium sulfate plus 2 units of hydrogen chloride. So in number 7, I've got aluminum, an element, iron 3 oxide, so I know because of the Roman numeral that's going to be 3. Oxide is oxygen, minus 2. Aluminum oxide, that's plus 3, minus 2. And iron is an element. Now I check aluminum, iron are not on my diatomic list, so it's just going to be their symbol. So that'd be aluminum plus iron 2 oxide, so that would be Fe2O3. Will give me aluminum Al2O3. I have to do the cross here. And iron is not on the list, so it's just Fe. So now I'm going to balance. I have 1 aluminum, but 2. So if I end with 2, I got to begin with 2. I have 2 irons, but I have 1 here, so I need 2. Remember, when you're balancing, coefficients go in front. Oxygens, I have 3 and 3. So 3 and 3, they're okay. So it's 2Al to 1 to 1 to 2. Now that one is balanced. Okay, ammonium nitrate plus nitrogen gives you hydrogen oxide. So ammonium, we know, is plus 1. Nitrite, is minus 1. Nitrogen is an element, so it's no oxidation number involved here. Hydrogen oxide, compound, so we know that's plus 1. Oxide is minus 2. So when we go to do this, ammonium is NH4, nitrite is NO2, okay? And it produces nitrogen. Nitrogen, I notice on my diatomic list, is N2, since it's by itself. And then hydrogen oxide, you have H2O. Okay, so now I'm going to balance. So, and again, nitrogens are always going to be left, or hydrogens are always going to be left last. So I'm going to count up my nitrogens. I got 1 here and 1 here. That's 2, and I end with 2. So they're okay. Hydrogens we're going to leave last. I have 2 oxygens here, but I only have 1. So I need 2. So I need a 2 there. And that also makes me have 4 hydrogens, but notice I have 4 over here. So now that one is balanced. And again, coefficients always, always, always go in front. And number 9, we have silver nitrate. That's a compound, so we know silver is plus 1, nitrate is minus 1. Copper is an element. Copper 2 nitrate is a compound, so we know that's going to be plus 2. It's going to be minus 1, and then we have silver as an element. So silver nitrate would be AgNO3 plus copper, which would just be Cu, will produce copper 2 nitrate, which would be Cu. I got NO3, and I need 2 of them, so I got to put it in parentheses. And plus silver, Ag. And I check, copper is not diatomic, so it's just a plain symbol, and silver is not diatomic, so it'll just be the plain symbol. So now I need to balance. So I have 1 silver, 1 silver. 1 nitrate group here, but I have 2, so now I need 2 here. When I did that, I just made my silvers 2, so now I got to give 2 down here. And then I have 1 copper, 1 copper. So that one would be balanced. The last one we got here, we have hydrogen element, nitrogen element, and ammonia, which is a compound, and it's a strange one, and I'm going to give it to you. It's NH3. Ammonium is NH4, but is NH3. So you want to add that to your list. Hydrogen is H, but it's diatomic, so it's plus 2. Nitrogen is N, but it's diatomic, so it's N2. Okay, so it has to be written this way. Now we need to balance it. And again, we do hydrogens last. So I have 2 nitrogens, but I have 1. So I need 2. Now my hydrogens, that 2 is 3, so there's 6 total there. So I'm going to need 3 over here to make 6. So this is how you would balance that one. So now that is balanced. So ammonia, you want to add to your list. You can just write it on the bottom. It's something that you can have on your list to remember. Ammonium, remember, is diatomic, and that was NH4 plus 1. And this is ammonia, so it's a little bit different.